my goodness. So we're going to draw some electron dot, and then we'll do some Lewis structures. This should be really fun to do. Most of you guys know how to do some electron dot. We'll start off easy, and then we'll work our way up to something a little bit more complex. This won't take very long because I'll go as fast as I possibly can. Let me get a color that we can all see. I'm using dark blue. Let's switch that to purple. Okay, so first of all, we have to know how many valence electrons we have. So remember, valence electrons are just down the table. 1, 2, 3. We're skipping the D block because the D block is never in the outer shell. 4, 5, 6, 7, and then 8 for everything below helium, 2 for helium. It doesn't really matter because helium and neon aren't going to be any compounds, at least nothing that we draw, right? So it's not that big a deal. All right, so let's pick some things and draw them out. So randomly, aluminum. Oops, come on, aluminum. Oops, why is that not letting me circle that? Oops, I have something on here. Okay, so aluminum. No, it's still not doing it. Okay, aluminum. There we go. Look above it. Aluminum has 3 electrons in the outer shell. So what do? You write down Al, and then you're going to dot around 1, 2, 3. It doesn't really matter where you start. The thing that matters is you're going to put 1 electron on each outer spot, each side of the invisible square. What invisible square, Mr. Arnold? Well, there's an invisible square around this thing. If you look real close, you can see it's in green. And you're going to put 2 dots on each side of that invisible square until you have it all filled up. And then from there on out, you are going to double them up. You cannot have more than 8 because the maximum outer shell electrons is 8. And I moved that table a little bit so my 8 is out of whack, but we know where it belongs. All right, you want me to pick another? And I will. This looks like I'm in green, but I'm going to increase that font. Okay, let's do BR. BR has 7. BR. 1, 2, 3, 4. 1 on each side. Now double. 5, 6, 7. You could have started anywhere you wanted. BR. 1, 2, 3, 4, 5, 6, 7. Right? It doesn't matter. You're going to change them where you want them anyway when you draw structures, so just get used to it. Okay, you want one more? How about BA? BA. 2 dots. 1, 2. See, if there's just 2 dots, you just do that. Good enough. All right. Hope there's no questions with that. That's pretty simple. Okay, now we're going to draw some structures. It's easiest if we pick the honks. What are the honks, Mr. Arnold? Well, I'm glad you asked that. Honk. H. Cut that out. Okay. I'm going to start over. All right, so let's draw some compounds. Let's see, let's draw something fairly simple. Let's do methane. All right, methane is CH4. I know most of you got through the chemistry section, the organic chemistry section. This will be no problem, right? We're going to start with our C. C has 4 dots. 4, right? 1 on each side. 1, 2, 3, 4. Hydrogen has 1 dot. Okay, and so let's change colors. I like to show this contrast here. There's 1 and there's his dot. There's 1 and there's his dot. There's 1 and then here's the dot. And there's 1 and their dot. Okay, now we're going to use our imagination. Look at that carbon in the middle. Oh my gosh, look. It has 8 electrons around it. Its octet is fulfilled. It's happy. Now, oops, I lost the green dot. Now, hydrogen can only have 2 dots. 1, 2. There's only 2 spots. 1, 2. There's only 2 spots in its shell. It only has the 1 shell. And if we'll use our little imagination again, look, its octet is fulfilled. And I did the little quoting marks because even though I said octet, it only has 2 electrons in its outer shell, so it's really it's still full. It has a full shell, and that's what's important. Okay, so that's that. All right, now let's do some other weird things here. I'm going to stay with the carbon compounds. Let's do C2H4. Oh my goodness, that seems fun. Okay, so we'll draw our C first. Now, if you have 2 C's in the middle, or if you have 2 C's, they're going to be in the middle, right? I always like to say, put the thing that has the most open or unpaired electrons in the middle. In this case, carbon has 4 unpaired electrons, which is the most unpaired electrons you could possibly have. So put it in the middle with its partner, the other carbon with 4. Oh, look, there's a nice bond right there. Okay, now we'll look at this thing. All right, now we have what? 4 H's. All right, so we're going to make this look symmetrical. Why are we making it look symmetrical? Because we are. We're going to do it because that's the way it's going to work, okay? So I'm going to put this H out here, doop, and there's its spot, it's bonded. Put another H out here, there's its spot, it's bonded. And now look, I have some extra spots here. Let's do the bottoms. Put an H here, bond, H here, bond. Problem. We have, and I think you see this already, if you don't see this, we have 2 unpaired electrons, right? 1 on each carbon. So what we're going to do is we're going to pair these 2 unpaired and create what we call a double bond. So the double bond, you can't do this at your home, but I can do it on mine. So the double bond will look more like this here. So I can take this and I can lasso this out, and I'm going to stretch this out and give myself a little bit more room. Well, that was cool. It did in the yellow there. I didn't know it would do that. And then I'm going to take and move those electrons down in between because, come on, let me circle you. Why aren't you letting me circle you? Oh, come here. Come here. Yeah, there. Oh, oh, come over here. Technical difficulty. Well, there he goes, and I'm going to move him in here. And I'm going to take this one over here and move. No, come over here and move you down there. Oh, okay. And voila. Now we have 2 pairs of electrons being bonded in there. And that's the old-fashioned double bond. Right? Just this one, right? And the others these were single bonds, if you haven't figured that out by now. All right, we'll do one more. That's a triple bond. Okay, so we'll do C2H2. This is a sibling. So we put a C here in the middle. And C goes in the middle because, of course, C has all those unpaired electrons. And then we're going to throw our extra H out here. And there's its bond. And the H out here, and there's its bond. Now look what we have here in the middle. 1, 2, 3. 3 that need paired up between the carbons. And so what we're going to do is we're going to take those and we're going to move them. And I'm not going to try that fiasco I did last time, so I'm just going to move them in here. Oh, no, 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 no. Oop. And we're just going to move those. That darn thing. That darn thing. Yeah, let's try that again. And we'll just move those to the middle. And so we had 1, 2, 3, 4, 5, 6, or 3 pairs of electrons. And that, of course, is the triple bond. Okay, that's electron dot. Lewis structure works the same way. Instead of showing 2 pairs of electrons, or instead of having a pair of electrons as a bond, we're going to draw a dash as a bond. So I'm going to draw the same ones we have. This is where I like to use what I call the honk rule. H has 1 bond it forms, O has 2 bonds it forms, N has 3 bonds it forms, and carbon has 4. Honk. So that will help you do this quickly. All right, let's throw out a water real quick. There's an oxygen, right? Hydrogen, hydrogen. There's one bond from each H, and then 2 bonds from each O. All right, let's draw that. Let's draw that methane again, right? Remember, it was C. Let's do it right here. C, 1, 2, 3, 4, and an H goes on each bond. What's that? You want to draw this other one too? 1, 2, 1, 2, 3, 4. Right? And we know how to do this with the carbons especially, right? And let's do this one too. C, 1, 2, 3. Okay, so if you're not sure how you're doing that, just follow that honk rule or go back to your electron dots. That's all I'm going to show you that for that today. Just a little reminder, and I hope you have a great day, and good luck with that section.